Okay, guys, there are two more questions I wanted to go over. So let's do this and then we'll be done. Okay, so this question, we will actually factor the denominators first before we can find the LCD. All right, so then 4 is another way I can write 4 is 2 squared. So you know how when you find LCD, it's best when you write everything in terms of prime number. So that's why I changed it to 2 squared and n minus 1. Because then I don't need to write 2 again because it's already included. Alright, so this is basically 12 n plus 1 and n minus 1. So my LCD is 12 times n plus 1 times n minus 1. And I'm going to multiply this to each of the fractions just like we did before. It's just going to be a little bit longer because we're going to end up having a quadratic equation. Let's see. So 3 and 12, so 7n times 4 times n minus 1 minus 5 times 3 and n plus 1 because I already had n minus 1, so it cancels. 3n times 6 times n minus 1. Okay. So 28n, n minus 1 minus 15, n plus 1, 18n times n minus 1. So you can tell that there will be some n squares here. So 28n squared minus 28n minus 15n minus 15. 18n squared minus 18n. So when you have a variable square after you simplified everything, my suggestion is move everything to the one side. Okay? And then make the other side equal 0 because we will have to factor and we'll have to factor. Alright, so GCF in this case would be 5. So I can divide everything by 5 because the other side is equal to 0. So I'm dividing everything by 5. And then I'm going to actually write it over here. It was 2n squared minus 5n minus 3 equals 0, right? So this factoring, again, you need to remember, what is the two numbers that multiplies to negative 6 but adds to negative 5? It's negative 6 plus 1, right? So when I have that, I rewrite it as like this. And then you group them. So I hope you remember this factoring. I know we didn't have to practice it for a long time. And then you find the greatest common factor. And this one would be 1. And again, you factor out the common things, which is n minus 3. Then I have 2n plus 1 left. We're not done because we need to set this equal to 0 and this equal to 0. So n minus 3 is equal to 0 when n is equal to 3. And 2n plus 1 is equal to 0 when 2n is equal to negative 1. So then n is negative 1/2. I know you're thinking this is such a long problem and we still need to check these two answers. And you're right. So we will do that, okay? We'll do it together. Let's check the n equal 3 first. And please feel free to use a calculator when you're checking, okay? 21, because 7 times 3, 9 plus 3 minus 5, 12 minus 4, equal 9 over, 6 plus 2. So basically, I need to have these two equal to each other. And I'm just going to use a calculator because I just need to check quick if they give me the same answer. And it does. Okay, so n equal 3 is part of my answer. And what about n equal negative 1/2? That's negative 0.5. So let's check that one too. So negative 0.5. So then negative 2, negative 4, negative 0.5, negative 1 plus 2. So again, I'm just going to check quickly on my calculator, and I hope you do that when you're solving your homework problems. And also, it is correct. So I have two answers for this problem: n equal 3 and n equal negative 1/2. So they are both my answers. Let's do the last problem. This one needs a little more factoring before this one. It's p plus 4 and p minus 2. Right, because 4 times negative 2 equals to negative 8. 4 plus negative 2 is plus 2. So then my LCD is p plus 4 times p minus 2. And we are going to multiply this to this fraction, and that fraction. So let me zoom in so I can have a little more space. So this would be p plus 4 because p minus 2 cancels with one another. And this one, everything gets canceled, so there's nothing left. And this one would be just p minus 2 left. So p plus 4 is equal to 2p plus 1 plus 2p minus 4, since I'm distributing here. And then let me move p to the other side. And then this is 4p minus p, so 3p minus 3, because 1 minus 4. So let's add 3. 7 is equal to 3p divided by 3. P is equal to 7 over 3. Not done yet because we need to check for our answers. And I know that is not a fun part. But we have a calculator, so, and especially when your answers are like a fraction, it's really not fun, and I get that. I feel the same. But it is an important part in mathematics to check your answer, because why do you do all this work if your answer is not even correct, right? All right, so let me quickly do this, and then I will tell you whether it's correct or not. And then we'll be done for today. Yeah, sorry, today is a little long. It's because I didn't realize how long these two problems would take. Yep, they are the same. So when you check with your calculator, you might think, oh, well, because of the decimal and the rounding issue, you might think they're not the same, but they are the same. So this is it. This is today's work, and I will see you after the long weekend. I hope you get lots of rest, and feel free to contact me if this lesson was not easy to understand. Okay, I'll see you next week.